Chapter 3, Section 3.3, Mean. The mean is the most common average, one you have doubtlessly calculated many times. The mean is found by adding all scores and then dividing by the number of the scores. That is, mean equals sum of all scores over number of scores. To find the mean term for 20 presidents, add all 20 terms in Table 3.1 to obtain a sum of 112 years, and then divide the sum by 20, the number of presidents, to obtain a mean of 5.60 years. There is no requirement that presidential terms be ranked before calculating the mean, even when the large sets of unorganized data are involved. The calculation of mean is usually straightforward, particularly with the aid of a calculator or computer. Population. A population is a complete set of scores. A sample is a subset of scores. For example, if the terms of the 20 U.S. presidents are viewed as a population, then 5.60 years qualifies as a population mean. On the other hand, if the terms of the 20 U.S. presidents are viewed as a sample from the terms of all U.S. presidents, then 5.60 years qualifies as a sample mean. Not only is the present distinction entirely a matter of perspective, but it also produces exactly the same numerical value of 5.60 for both means. This distinction is introduced here because of the importance in later chapters, where the population mean usually is unknown, but fixed as a constant, whereas the sample mean is known, but varies from sample to sample. Until then, unless noted otherwise, you can assume that we are dealing with the sample mean. The formula for the sample mean. It's usually more efficient to substitute symbols for words in statistical formulas, including the word formula given earlier for the mean. When symbols are used, X bar designates the sample mean and the formulas become. The sample mean is the balance point for a sample found by dividing the sum for the values of all scores in the sample by the number of scores in the sample. Sample size, the total number of scores in the sample. So in 3.1, it shows the formula written out for you on how to follow. X meaning all the sample scores added up, and N being the total number of scores in the sample. Population mean. A population mean is the balance point for a population found by dividing the sum for all scores in the population by the number of scores in the population. Population size is the total number of scores in the population. Where we have the mu, which is the population mean symbol. It's similar to the sample mean, but the N is capitalized in the population mean, and in the sample mean, the N is lowercase. So in Table 3.3, is the term and years of 20 recent U.S. presidents, where we got examples for population and sample. Mean as a balance point. The mean serves as a balance point for its frequency distributions. Imagine that the histogram for terms of the 20 presidents in Figure 3.1 has been constructed out of some rigid material such as wood. Also imagine that while using only one finger placed under its base, you wish to lift the histogram without disturbing its horizontal balance. To accomplish this, your finger should be at 5.60. The value of the mean shows as a dot in Figure 3.1. If your finger were to the right of this point, the entire histogram would seesaw down to the left. If your finger were to the left of this point, the histogram would seesaw down to the right. The mean serves as a balance point for its distribution because of a special property. The sum of all scores expressed as positive and negative deviations from the mean always equals 0. In the right-hand column of Table 3.3, each presidential term reappears as a deviation from the mean term, obtained by taking each term, including duplications, one at a time and subtracting the mean. Terms above the mean of 5.60 reappear as positive deviations. For example, 12 reappears as a positive deviation of 6.40 from the mean, since 12 minus 5.60 equals 6.40. Terms below the negative deviation of negative 3.60. Terms below the mean of 5.60 reappear as negative deviations. For example, 2 reappears as a negative deviation of negative 3.60 from the mean, since 2 minus 5.6 equals negative 3.60, as suggested in Table 3.3. When the sum of all positive deviations, 21.6, is combined with the sum of all negative deviations, negative 21.6 is resulting sum of 0. In its role as balance points, the mean describes a single point of equilibrium, at which once all scores have been expressed as deviations from the mean, those above the mean counterbalance those below the mean. You can appreciate, therefore, why a change in the value of a single score produces a change in the value of the mean for the entire distribution. The mean reflects the values of all scores, not just those that are middle ranked, as with the median, or those that occurs most frequently as the mode.